to the Coders Campus podcast, where you'll learn how to code from one of the best teachers in the industry. Whether you're an absolute beginner or a seasoned pro, the Coders Campus podcast will teach you what you need to know to master the art of programming. And now, your host, Trevor Page.
Ladies and gentlemen, boys and girls, children of all ages, welcome to the Coders Campus podcast. I, as always, will be your host, Trevor Page. Welcome to episode 3 of the podcast. If you've listened to the previous 2 episodes, which I would highly recommend doing, then welcome back. And remember, I'm looking for ratings and reviews from you guys to help me bolster this brand new podcast that I've launched into iTunes. So, like I said, I'm going to be picking a winner just by the end of August. If you haven't already left a rating and review, please do so. $100 gift cards on the line, as well as 2 free memberships to my Coders Campus community, where it takes you from zero to hero when it comes to creating and becoming a full stack Java web application developer. All right, cool. So say no more, coderscampus.com/review to do that. That is it. That's all I'm going to say about it. Let's get rocking with today's episode and get right into the good stuff. So, in last episode, number 2, we left off talking about the CRUD. We're talking about the create, read, update, delete statements that everybody does. This is day in and day out. This is what programmers do. They do CRUD on any application on any platform in any language. CRUD is at the center of what makes applications useful, right? Creating, reading, updating, and deleting data. So, in the last episode, we talked about Spring Data and how Spring Data makes our lives easier because in one line of code, you can create what's called a repository to be able to do the CRUD operations on your database. So all you need to do is create a new interface, call the interface whatever you like, but typically you want to call it the entity name followed by the word repository. So we're talking about a food diary. We're talking about tracking our food consumption in terms of the cost of the food, the type of food, if it's a breakfast, lunch, dinner, snack type meal, so on and so forth. So we create the food diary entity, which is the Java object representation of a database table. So we created the food diary entity, and then we created a food diary repository. So you see, take the name of the entity, you tack on the word repository. So food diary repository, you created that interface, and then we had that extend the JPA repository JPA repository object. And you pass it requires a templating generic. So in the angled brackets, we pass in the entity that we want to be interacting with. So it's the food diary entity. Pass in the food diary, pass in the ID of the data type of the ID, which we're using a long to store our IDs. You could also use an integer, but I'm using a long, so we pass in the long for our Spring Data, and that's it, done. Essentially, in 60 seconds, I've explained how you can create a JPA repository, or more specifically, the Spring Data repository. So we've already talked about how to create via save, by doing the food repository.save, how to create something. We talked about how to read data via food diary repository.findAll or .findOne, where we pass in an ID. Now I want to talk about updating and deleting. So that is what is on deck for this episode. Now, believe it or not, if you were actually playing around with the code that we wrote in the sections above, so if you went to coderscampus.com/2 and saw the code, then you may have noticed that updating an existing record seems to already work. So if you already were playing around with it and whatnot, you'll notice that it already works. So why is that? Why does it already work? The job is done, but what happened? So let me explain why it works. So you see, when you use Spring Data to execute the findOne, or maybe findAll, but in our case it was .findOne, it grabs the ID of the entity, right? We put the entity on the model and we pass it to our view. So essentially, what happened was we remember we were listening on localhost 8080/food diaries/ the food diary ID. So in our case, /1, let's say, to grab the first food diary item. We did the query to do a .findOne, and we passed in that ID, the food diary ID. We pass that in, so we grab that entity from the database and we assigned it to a Java object. Then we put that Java object on the model. And that's the key there. That's why this works. When we did the query to do the findOne to get that one object, and then we put that object on the model. Well, the model inside of our view, it's linked to that model. It's linked to that food diary item. So because it's linked to it, it automatically populates the data inside the food diary item that was just queried from the database. And the other beauty is when we edit that data and then click save, click the submit button, it's just going to send that data back over to our controller, and it's going to, again, pass that in as a model attribute, and then the controller will save that to our database. Now, here's the key. Here's the key to why this thing works. It's because it is already populated. It already has an ID field populated. Okay? So when the view passed the entity back, the ID was populated. So when the ID of an entity has a value, in this case, the food diary is our entity, the food diary ID inside of the food diary object has a value. So first of all, how does it have a value? How does it know to have a value? Well, that is in the way that we created our code in our entity. Our entity automatically generates IDs when they get saved to the database. We did that via the @generated_value annotation back in the last episode when I was talking briefly about JPA stuff. Because we have the @generated_value, it will automatically generate an ID when we invoked the save. So when we did the C part of CRUD, when we did the create, which did the insert, when it inserted that object, the food diary object, into the database, it generated an ID for that object. The ID that it generates is, well, the ID number 1. If there's no other rows in there, and if this is a brand new application, the ID that it generates will be 1, because that's the first ID that it wants to hand out, is 1. If you save in something else again and create and do an insert, then it's going to give ID 2, and then ID 3, 4, 5, 6, etc., etc. So it's given it an ID. So because it's given it an ID, that ID exists in the database. When we performed the food diary repository .findOne, we wanted to query, do the read part of this CRUD operation, we read that item from the database with ID 1. That Java object that was read from the database populated the ID field because it has one. It's able to populate it, so it does. And when we pass that to the view and then subsequently modify the stuff on the view and hit, save, it's going to pass back to our controller the same object that has the ID. So when the ID of an entity has a value, in this case the value of 1, when the ID of the entity has a value, Hibernate knows that that entity must already exist in the database. Okay? The only way that the ID field could be populated is if it was already saved into the database. Because otherwise, why the heck are you just randomly assigning IDs to entities that shouldn't have one? Okay? So, in other words, when you save an ID, when you invoke a save, not save an ID, when you save an entity, when you invoke the .save for an entity that has not already been saved to the database, the ID property will be blank. It'll be null. So that is the flag that Hibernate needs to know to do an insert. So it's going to do an insert because it's a new row because it doesn't have an ID already. But if you do the exact same thing, you invoke a .save, just like we did before, but the entity that we're passing into the save method, if the entity has an ID value, that's not null. So if it has an ID like 1 or 2 or 3 or 24 or 4 million, whatever the case may be, if it has an ID, Hibernate knows that entity must already exist in the database, and therefore it must execute an update, not an insert. So when you invoke the .save, the food diary repository .save, and you pass in that food diary item, if you will, it has an ID, so it knows to do an update and not an insert. So you see here, it's actually Hibernate that's doing the heavy lifting for us, because the ID is already populated with a value, so Hibernate knows to do an update, and it's going to update that record with all of the data that is currently inside of the actual entity itself. So the meal type, the food item, the time of day, the cost. It's going to update all of that with whatever it is that was typed in the view, even if whatever was typed in wasn't changed. Okay, so if you submit it and you didn't change anything, it's going to just overwrite the values in the database with whatever it is that you passed in. In other words, it's going to overwrite the values with the same values, so it's not going to have any effect. Okay, but if you happen to change something like the cost or the type of food or the time of day, whatever it is, if you changed it and said save, then it will update with whatever it was that you just typed in, which is exactly the functionality that you want. That's exactly the functionality that you're looking for when it comes to doing updates. So you see, in fact, this has nothing to do with Spring data and has everything to do with Hibernate. But it's how they play together and makes it absolutely seamless to you that makes it so cool. Okay, so you might have already been familiar with that kind of concept of Hibernate with, if you have an ID populated, it'll do an update. If you don't, if it's null, it'll do an insert. You might have already known about that. If so, great. There's nothing that's different here. Spring data with the repository, you just do a .save and it's going to still do everything that you expect it to do. If you didn't know about that, then hey, congratulations, now you know. Again, I have a whole series on Hibernate. I believe I did a whole series on Hibernate on my previous podcast. So if you want to look at past episodes of this podcast that are pre-episode 1, if you will, of this podcast, you can go and check it out at coderscampus.com/podcast. I think I've done about 65 episodes. Actually, you know what? I'm going to find out. I'm going to find out what the exact numbers are. I'm going to fire up my iTunes environment right now, and I'm going to find out in my old podcast how many episodes I had published. Now, I just realized I can't open iTunes to do it because it's no longer listed on iTunes, which is the root of the problem that I am currently facing. So I'm going to go to coderscampus.com/podcast right now, and I'll find out the last known episode that I had posted for the How to Program with Java podcast. Yes, okay. It was episode 65 was the last episode I'd posted for How to Program with Java. So this is essentially episode 65 plus 3. So we're essentially on episode 68 of the How to Program with Java podcast, but I can't call it that because of trademark infringements. In any case, I did do episodes on Hibernate, specifically starting at episode 50 of the previous podcast. So if you want to check that out, go to coderscampus.com/podcast, and you'll be able to go and sort of iterate through all the different episodes that I had previously published. So check it out, starting at episode 50. If you don't know about Hibernate already, that's where you can go to learn everything that your little heart desires. So let's now go back to the next topic, which is the D in CRUD. We have arrived finally at the final letter in the word, or in the acronym CRUD. D stands for delete. So let's start with an example of how we can delete something. So when deleting a row from the database that contains a simple object like the food diary object, it's very simple to perform a delete operation. In fact, all you need to do is invoke a .delete, and you pass in the object that we wish to delete. Okay, so really all you need to do is, let's say we wanted to invoke a delete, so we could maybe create a new method in our controller. The request mapping of this in our controller could be food diaries / food diary ID, which is in curly brackets in our is it not parentheses? What are curly brackets called? Maybe curly brackets? Maybe that's what you call them? Sure, that's what I'll call them. So you wrap your food diary ID in curly brackets. You can call this whatever you like. You can call it ID, food diary ID, food ID. I don't know. I don't care. Whatever you want to call it whatever you want. But then the method now, for this, we'll do a method as a post. And we'll pass in a parameter. We can pass in params, and we'll say the action equals delete. So that way we know when we invoke a post where the parameter passes an action of delete, we know we're actually trying to invoke a delete and not, let's say, an update or something like that. But again, that's neither here nor there. That's more Spring MVC stuff. That's not really Spring data stuff. So in order to delete an item, we always need to load the entity from the database before we perform a delete. So I wouldn't recommend manually creating a brand new item, a brand new object, and sort of willy-nilly just sort of populating that new object with an ID or something. Make sure you load it from the actual database first, because there's there's things at play here that you might not understand in terms of Hibernate and the way Hibernate works. Hibernate, you need to have the object in context in terms of it being loaded from the database. Just take my word for it. Load it from the database first. So you load the item. We have a food diary ID that we're passing in to our URL that we want to delete. So just do a findOne. So we use our food diary repository dot findOne, okay, which is just a read statement. We've done a read before. We've talked about it in the previous episode. You do a findOne and you pass in the food diary ID. So that will load that one food diary ID. So let's say, for example, we want to delete food diary 1, item 1. So we pass in food diary 1 to the findOne method, and it will return a food diary item, object. Okay, so you assign that object to a variable, and then you invoke food diary repository dot delete, and you pass in that food diary object, and that's it. So you load it from the database, load it into a variable name, pass that variable name into the dot delete of your repository, and you're done. It's deleted that object. It invokes the delete statement on the SQL side. Poof, it's gone out of your database. Pretty straightforward. Okay. Like I said, most importantly, just make sure you load the entity first, and then you pass that loaded entity into your delete method, and then you will be all set. So again, we could just call it quits here. I could just say thanks so much for listening. Take care of yourself. Bye for now. But I'm going to get a bit deeper into a more complex scenario. So what other complex scenarios could there be here when it comes to deleting objects? Because it seems pretty straightforward. Well, believe it or not, when you have relationships inside of your objects, then things get a little bit more tricky. So I've talked about relationships in the past episodes of the podcast. So again, what is it? Episode... Oh, let's have a look here. Starting with episode 53, I start talking about relationships with Hibernate, all the way to so from 53 to 56. Yeah, so 53 to 56, I talked about relationships. So if you don't know about those, go to coderscampus.com/podcast and check them out. But if there is a relationship that exists in your entity, things get just a little bit more complex. So why do I say why is it more complex? It's more complex because when you have, let's say we are wanting to delete, I think it's a child. If we want to delete a child side of the relationship, it gets a little bit tricky. If you want to delete the parent side, it's pretty simple. Let's say we had a parent. The food diary item was the parent. Let's say we had food diary sub item that was a child to food diary item. So a food diary sub item, we want to delete, the food diary item and all of its children. Then you do exactly what we just talked about. You delete the parent object, and it should, so long as you've assigned a cascade to it in your entity object itself, you should assign a cascade to the relationship. Again, I don't want to get into relationships right now. I want to get into Spring data. If you've assigned a cascade to your relationship, specifically a delete cascade, it will delete the parent and all of its children from the database. Cool? Done. Great. Fantastic. Again, Bob is your uncle. So that's the easy part. The harder part is if you want to delete one of the children from the relationship. So let's say our food diary item is a child in this relationship. So let's see. We could have a user. Okay, we have a user item, a user entity. The user entity could have a one-to-many relationship to food diary items, food diaries. So in other words, one user can have many food diaries or food diary objects, which kind of makes sense, right? If you want to log in, you log in with your username. You want to create as many diaries as you want. You can create as many diaries as you want to say, okay, here's what I ate today, and I ate this for breakfast, and this for lunch, and this for dinner. Makes sense. You're one user, and you have many items that you've added to your food diary, repository. So that makes perfect sense. That's a one-to-many relationship. But let's say you made a mistake. You want to delete one of the food items. You realize, that was I don't know, maybe maybe you felt ashamed because you ate that thing, whatever that thing was, and you want to delete it and pretend like it never happened. So that's the situation you want to be in. It makes it a little bit more difficult to actually delete because of the fact that it is a child in a relationship. So in order to properly delete the child, you need to follow some steps. So the first thing that we need to do is we need to, get the food diary item, if you will, from the database. So we still do food diary repository.findOne, and you pass in the food diary ID. Nothing different here. We've already talked about doing that before. The difference is we also want to get the user that exists inside of that food diary item, right? So the food diary, remember, is on the food diary side, which is a child side, it has a many to one correlation to users. So in other words, from my food diary items, so let's say I have my pizza, I had a pizza at noon and it was, $15. I have a pizza at noon, $15 for lunch. I load that item up. That item is going to contain a pointer that points to the user that created it. So this one food diary item in the database it belongs to one and only one user. Hence the one-to-many relationship. We need to get that user from the food diary item. So you can just actually do food diary, dot get user, because we'd have to change the entity itself. I didn't talk about changing the entity, but you can see all the code on coderscampus.com/3 for episode 3. You'll see exactly what I'm talking about with the entity and the changes to the entity. But we'll be able to execute a get user on it. That doesn't come from Spring Data. That comes from us. We put that in there. So great. We get the user. Now what we need to do is we need to actually remove the user from our food diary item. Okay. And we need to, let me make sure I'm saying this correctly. Yes, we need to remove the user from the food diary item, and we also, conversely, we need to remove the food diary item from the user. So removing the user from the food diary item is quite simple. We just say food diary item dot set user, and then you set it equal to null. That's easy. The harder part is you need to find from the user, you need to remove that single food diary item from the user. So what we just talked about was from the child side, it's easy. From the child side, you say food diary item dot set user null. Done. That's easy. From the parent side, the parent side is the user. The user has many food diary items. So we need to iterate through all the food diary items to find the one that we need to remove. So that's kind of a pain. You'll see the code, you just iterate through. You say user.getFoodDiaries, which gets all the food diaries. And then you find the item that equals the actual food diary item that we loaded from the database. You find the equivalent one, and then you invoke a dot remove. So you're doing Java collections now. You do user dot get food diaries dot remove, and you remove that food diary item. So essentially what we're doing here is we're removing the pointers from both sides. From the parent side, we delete the child. From the child side, we delete the parent. Okay? And then you invoke your food diary repository dot delete. And obviously don't forget to pass in the actual, child item that you would like to delete, the food diary item that you want to delete. And that should do everything that you want it to do. Now, the other thing that you can do, if you're lazy and you don't want to actually have to execute the dot delete statement, I think there's a way to enable orphan removal. So I don't remember exactly what the syntax is, although I could probably Google it right now. If you want, you can enable orphan removal, which is probably in the relationship itself. You can say orphan removal or something like that, or remove orphans equals true in the relationship on the parent side. So if I look through, here it is. Okay, so in the one-to-many, the at one-to-many relationship, you can say, orphan removal equals true. Okay, and if you do that, then all you need to do is remove the child from the children. So again, the user dot get food diaries dot remove, and then the child that you want to remove. And then you can say, if the child is not null, essentially you can say the child dot set parent equals null, or set parent null, and then you don't have to say dot remove. It'll just it'll leave the transactional context, and it'll just know to remove the child from the parent because you told it to. essentially, and it has the orphan removal set to true. So if that's the case, there you go. It'll do it for you automatically. And, in looking at other people's code, now that I went back and looked at other people's code, I'm wondering, I don't believe, when I spoke earlier, I spoke about how we needed to iterate through the food diary items, find the one that's equal to, that's inside of the list of food diaries inside of the user, and then we use that to remove it. I realized you don't actually need to do that. I'm not sure why I said that you need to do that. That's kind of redundant task, because you already had the food diary item that you've loaded from the database that you want to remove. So I would like to go back and remove that code from what I talked about in my previous statement. So all you do is you get the food diary item via the .findOne. You get the user from the food diary item that you just loaded. You then say user.get fooddiaries.remove the food diary item that you just queried for. And then you say the food diary item dot set user null. And then you need to invoke the delete on your repository if you don't have orphan removal turned on. Or if you have orphan removal turned on, then you don't have to put .delete. And again, Bob is your uncle. So there you go. I just gave you 2 different ways to do deletes. Actually, 3 different ways if you count the first easy way without the relationships in it. But there you go. There's a bunch of different ways, and that's just the way it is when it comes to, that's all Hibernate specific stuff. The Spring Data part is really as easy as the .delete. Okay, that will take care of it all for you if you don't have orphan removal turned on. That is a Spring Data responsibility part of this whole thing. So, that was a lot of work to talk about Spring Data. But again, once you implement Spring Data, it takes way longer to explain it than it does to just use it. Because really, Spring Data, in the grand scheme of things, is really only 3 or 4 lines of code total, right? What you can do, perhaps what we can do for the 4th episode, is get into Spring Data in terms of writing custom queries, because I know that is something that I often had to do, is to create custom queries. So if you don't want to use the ones that are just out of the box, that come with the JPA repository when you extend JPA repository, if you want to do more than just the standard findAll, findOne, save and flush and delete and that kind of thing, then you need to create your own custom queries. So in episode 4 of this podcast, we'll dive into the custom queries that you can create with Spring Data. Again, it's not that complex at all. That's the beauty of Spring Data. There's a lot of stuff by convention that you can do to automatically create queries without even having to, lift a finger, so to speak. So there you go. Thanks so much for listening to this episode. This has been episode 3 of the Coders Campus podcast. You'll be able to access the show notes via coderscampus.com/3. And like I said at the top of the show, please do leave a rating and review. I'm running a contest. You'll be able to get a $100 gift card, Amazon gift card. You'll be able to win one if I pick your name. So leave a rating review by going to coderscampus.com/review. Take a screenshot of your review. Send it to Trevor at craftycoder.com. That's Trevor at craftycoder with no E.com. If you put E in Crafty Coder, you have it spelled incorrectly. Send it to me. I will then pick on, I believe it was August 27th was the final date that I decided upon. Let me scroll down. Or is it August 26th? Hold on one second. I said 8 weeks from July 1st. 1, 2, 3, 4, 5, 6, 7, 8. So August 26th will be the final day of this contest. I will be picking a winner on that day, and you'll win a $100 Amazon gift card for whatever country that you live in, whatever $100 is equivalent to in your country. I will buy you that gift card for you personally and deliver it to you via hopefully email or by snail mail if I have to do it via snail mail. But hopefully Amazon allows you to type in an address and just ship it through Amazon. Hopefully I don't have to do that. But hey, I will be willing to do that for you. If you go through the trouble of leaving me a rating and review, it will be my pleasure. And for, prizes 2 and 3, I will be giving away 2 free months to the Coders Campus membership community, where you can learn to become a full stack Java web application developer from zero to hero, where you can actually land a job and get hired, or just show off your skills to your own mother. So, I look forward to seeing you guys in the next episode, which will be number 4. And yeah, it's been a pleasure, being with you for the past 3 episodes, and I look forward to, gracing you with my presence for the next 100 or more to come in the future. So take care of yourselves. Happy learning, and bye for now.
Thanks for listening to this episode of the Coders Campus podcast. But before you go, Trevor has a favor to ask you. In order to keep these episodes free, he'd love for you to leave a rating and review the podcast on iTunes. Just go to coderscampus.com/review to leave your own rating and review of the show. So if you have 30 seconds to spare right now, please help out by leaving a rating and review via coderscampus.com/review. It will ensure that you continue to get these awesome free podcast episodes each and every week. So if you like free swag, head on over to coderscampus.com/review. Happy learning!